The morning sun cast long shadows across the newly constructed KLA facility in Newport, Wales, as a convoy of black vehicles approached the main entrance. The semiconductor manufacturing plant, representing a significant investment in Welsh technology and employment, stood as a testament to modern industrial achievement. Prince William, dressed in a navy blue suit without tie for a more approachable appearance, stepped from the lead vehicle and was immediately greeted by the facility's leadership team. Dr. Sarah Chen, the facility's general manager, extended her hand with a warm smile. "Your Royal Highness, welcome to KLA Newport. We're absolutely thrilled to have you here today." Her genuine enthusiasm was evident as she gestured toward the gleaming building behind her. This facility represents not just technological advancement, but a real commitment to the Welsh workforce and community. The prince shook her hand warmly, his eyes already scanning the impressive structure. "Thank you for having me, Dr. Chen. I've been looking forward to this visit for weeks. The reports about what you're accomplishing here, both technologically and in terms of community impact, have been fascinating to read." As they walked toward the entrance, maintenance supervisor Tom Williams approached, wearing his best work uniform. He'd been with the company for 15 years, starting at their California headquarters before volunteering to help establish this new Welsh operation. "Your Highness," Tom said with a slight nervous tremor in his voice, "I just wanted to say how much this visit means to all of us. Having you here validates everything we've been working toward." Prince William paused, turning his full attention to Tom. "Please tell me about your experience here. You've been part of building this from the ground up, haven't you?" His genuine interest immediately put Tom at ease. "Yes, sir. I moved my family here from California 2 years ago when we started construction. My wife thought I was mad, leaving sunny California for Wales," Tom chuckled, his nervousness fading. "But this opportunity to help build something this significant for Welsh manufacturing, it felt like being part of history." "And how has the transition been for your family?" the prince inquired, showing the personal touch that had become his hallmark during public engagements. Tom's face brightened considerably. "Better than we ever imagined. The kids love their new schools, my wife has found work with a local engineering firm, and the community here has embraced us completely. It's been remarkable, honestly." Dr. Chen guided them through the main entrance, where the lobby showcased interactive displays highlighting the facility's capabilities and community partnerships. "We employ over 800 people here," she explained, "with plans to expand to over 1,200 within the next 3 years. About 60% of our workforce is local Welsh talent, with the remainder being experienced specialists who relocated here specifically for this project." The prince examined the displays with genuine curiosity, asking detailed questions about the hearing process and training programs. "How do you ensure that local workers can adapt to such highly technical positions?" he asked. "We've partnered extensively with local colleges and universities," Dr. Chen replied. "We developed specialized training programs that take motivated individuals with basic technical aptitude and provide them with the specific skills needed for semiconductor manufacturing. It's been one of our most successful initiatives." Security Chief Margaret Hughes joined the group as they prepared to enter the main production areas. A former police sergeant with 25 years of experience, she had been responsible for developing the facility's comprehensive security protocols. "Your Highness," she said with crisp professionalism, "before we proceed into the manufacturing areas, I'd like to brief you on our safety and security procedures. We take the protection of both our personnel and our intellectual property very seriously." "Of course," the prince replied. "I imagine the security considerations for a facility like this are quite complex." Margaret nodded. "Indeed, sir. We're dealing with cutting-edge technology that requires protection from industrial espionage, while simultaneously maintaining an open, collaborative work environment for our employees. It's a delicate balance, but one we've managed to achieve through careful planning and state-of-the-art systems." As they donned protective gear for the clean room areas, production engineer James Powell approached. A recent graduate from Swansea University, James represented the new generation of Welsh engineers that the facility was helping to develop. "Your Highness," he said with youthful enthusiasm, "I wanted to thank you for visiting us. As a young engineer starting my career here in Wales, seeing this level of recognition for our work is incredibly inspiring." Prince William smiled at James's energy. "Tell me about your role here. What does a typical day look like for you?" "I work primarily on process optimization," James explained, his passion for his work evident in his animated gestures. We're constantly analyzing our manufacturing processes to improve efficiency and yield. It's like solving complex puzzles every day, but with real-world applications that affect global technology supply chains. That sounds fascinating. How does working here compare to what you expected when you were studying? The prince asked. James considered the question thoughtfully. Honestly, sir, it's exceeded all my expectations. The level of sophistication in our operations rivals anything I've read about in international facilities. But what really sets this place apart is the collaborative culture. Everyone here, from senior engineers to maintenance technicians, contributes to problem-solving and innovation. Dr. Chen led them toward the main production floor, explaining the layout and workflow. What you'll see here represents some of the most advanced semiconductor manufacturing technology in the world, she said. Our equipment can measure and manipulate materials at the atomic level, enabling the production of components that are essential for everything from smartphones to medical devices. Shift Supervisor Patricia Evans, a 30-year veteran of Welsh manufacturing who had transitioned from traditional industries to semiconductors, approached the group. Her presence commanded immediate respect from the workers around her, and her pride in the facility was unmistakable. "Your Highness," she said with warm authority, "welcome to our production floor. I've been working in Welsh manufacturing for 3 decades, and I can honestly say this facility represents the future of our industrial capabilities." Patricia has been instrumental in training our workforce, Dr. Chen added. Her ability to bridge traditional manufacturing experience with cutting-edge semiconductor processes has been invaluable. Patricia smiled at the recognition. "The transition hasn't always been easy, sir. Semiconductor manufacturing requires a completely different mindset from traditional manufacturing, but the workers here have been incredible. Their willingness to learn, to adapt, to embrace new technologies has been remarkable." The prince observed the bustling activity around them, noting the obvious pride and professionalism of the workers. "What would you say has been the key to successful workforce development here?" "Respect," Patricia replied without hesitation. "Respecting the experience that workers bring from their previous careers while providing them with comprehensive training in new technologies. We don't treat people as blank slates. We build on their existing skills and knowledge." Research and Development Director Dr. Michael Roberts joined the tour as they approached the R&D section. A Cambridge-educated physicist who had worked for major technology companies worldwide before accepting the challenge of establishing this facility, Dr. Roberts brought both technical expertise and international perspective to the operation. "Your Highness," he said, "I'm excited to show you some of the innovative work we're doing here. This isn't just a manufacturing facility, it's a center for technological advancement." "What types of research are you conducting here?" the prince asked, his interest clearly piqued. "We're working on next-generation measurement and inspection technologies for semiconductor manufacturing," Dr. Roberts explained. "Our goal is not just to manufacture existing technologies more efficiently, but to develop entirely new capabilities that will enable future advances in electronics." As they walked through the R&D laboratories, technician Sarah Williams demonstrated some of the advanced measurement equipment. A local hire who had completed her training through the facility's partnership with Cardiff University, Sarah had quickly become one of the most skilled operators of the complex instrumentation. "This equipment can measure features that are smaller than viruses," she explained with obvious pride. "The precision required is almost unimaginable." "How did you prepare for working with such sophisticated technology?" the prince asked. "The training program here was incredible," Sarah replied. 6 months of intensive education covering everything from basic physics to advanced instrumentation. But the best part was learning from experienced engineers and technicians who were patient with our questions and encouraged us to really understand the science behind what we're doing. Quality Assurance Manager David Thomas, whose attention to detail had been crucial in achieving the facility's impressive quality metrics, approached with several samples of the components they produce. "Your Highness, these components will end up in devices used by millions of people worldwide. The responsibility of ensuring their quality is something we take very seriously." "What does quality assurance entail in this environment?" the prince inquired, examining the microscopic components. "Every aspect of our production is monitored and measured," David explained. We have systems that can detect defects smaller than 100th the width of a human hair. But beyond the technology, it's about creating a culture where everyone takes personal responsibility for quality. The tour continued through various departments, with the prince taking time to speak individually with workers at different levels. Maintenance technician Robert Davies, who had previously worked in the coal mines before retraining for his current role, shared his perspective on the economic transformation the facility represented for the region. "Your Highness," Robert said, his hands showing the calluses of decades of manual work. "When the mines closed, many of us thought our working lives were over. This place has given us a second chance, a way to be part of building the future instead of just surviving." "That transition must have required significant personal courage," the prince observed. Robert nodded thoughtfully. "It did, sir. Learning new skills at my age wasn't easy, but the support here from management and from fellow workers made it possible. And now I'm working with technology I could never have imagined when I started my career underground." Human Resources Director Linda Thompson, who had been responsible for developing the facility's innovative training and retention programs, joined the conversation. "Robert represents one of our greatest success stories," she said proudly. "The program that helped him transition has become a model for workforce development throughout Wales." "What makes your training program so effective?" the prince asked. "We focus on building confidence as much as skills," Linda explained. "Many of our trainees come from industries that have declined, and they often doubt their ability to master new technologies. We pair them with mentors, provide extensive hands-on training, and celebrate every milestone. It's about treating people as whole individuals, not just workers." As the morning progressed, the prince's interactions revealed a genuine curiosity about both the technical and human aspects of the facility. Environmental Compliance Officer Emma Roberts explained their sustainability initiatives, highlighting how the facility had been designed to minimize environmental impact while maximizing energy efficiency. "We're not just bringing new technology to Wales," Emma said. "We're doing it responsibly. Our energy consumption per unit of production is among the lowest in the industry, and we've implemented comprehensive recycling programs for both materials and water." "Environmental responsibility is crucial for any modern industrial facility," the prince agreed. "How do you balance the demands of high-tech manufacturing with environmental protection?" "It requires constant innovation," Emma replied. "We work closely with local environmental groups and regulatory agencies to ensure we're not just meeting current standards, but anticipating future requirements. It's an ongoing challenge, but one we embrace." The depth of engagement from the prince impressed everyone present. Unlike ceremonial visits where interaction is limited to pleasantries, his questions demonstrated genuine understanding of the challenges and opportunities facing modern manufacturing. Workers who had initially been nervous about meeting royalty found themselves in substantive conversations about their work and their aspirations. Apprentice Coordinator John Phillips introduced several young apprentices who were learning advanced technical skills while earning wages and working toward professional qualifications. "These young people represent the future of Welsh manufacturing," John said proudly. "They're combining traditional apprenticeship concepts with cutting-edge technology education." Apprentice Amy Chen, a 19-year-old from Newport who had chosen the apprenticeship program over university, spoke confidently about her decision. "Your Highness, when I heard about this opportunity, I knew it was exactly what I wanted. I'm earning while learning, gaining real-world experience with the latest technology, and I'll graduate with both qualifications and job experience." "What advice would you give to other young people considering similar paths?" the prince asked. "Don't be afraid of technology," Amy replied. "And don't feel like you have to choose between traditional education and practical skills. This program gives you both, plus the confidence that comes from actually building things and solving real problems." The morning had revealed not just a high-tech manufacturing facility, but a community of people who had found purpose and pride in their work. From experienced engineers to recent apprentices, from relocated specialists to retrained former miners, the facility represented a successful integration of advanced technology with human potential. As they prepared to move to the next phase of the visit, Dr. Chen reflected on what they had accomplished. "Your Highness, what you've seen this morning represents just the beginning. Our goal is to become not just a manufacturing facility, but a catalyst for technological and economic development throughout Wales. The prince nodded thoughtfully, clearly impressed by what he had witnessed. The technical achievements are remarkable, but what strikes me most is the sense of purpose and community among your workforce. That's what will sustain this success over the long term. The morning had set the stage for deeper conversations about innovation, community impact, and the future of Welsh manufacturing. As they moved toward the engineering and design areas, the prince carried with him a growing appreciation for the human stories behind the technological achievement, and the workers he had met knew that their voices had been genuinely heard by someone who understood the significance of their contributions. The engineering wing of the KLA Newport facility buzzed with controlled activity as Prince William was guided through areas where the most sophisticated work took place. The transition from the production floor to these specialized laboratories marked a shift from manufacturing execution to technological innovation. Here, teams of engineers worked on problems that would influence semiconductor manufacturing worldwide. Chief Engineer Dr. Alan Morrison, a soft-spoken Scotsman whose expertise in optical measurement systems had made him one of the most respected figures in the industry, welcomed the prince to the Advanced Optics Laboratory. "Your Highness, what we're developing here represents the next generation of precision measurement technology. The tolerances we're working with are so small they challenge the fundamental limits of physics." Prince William examined the complex optical systems with genuine fascination. "The precision required must present extraordinary challenges. How do you even begin to approach problems at this scale?" "It requires a combination of theoretical understanding and practical experimentation," Dr. Morrison explained, his hands gesturing toward sophisticated equipment. "We start with fundamental physics principles, but at these scales, we often encounter phenomena that textbooks can't fully explain. Our engineers become explorers, really, pushing into territory where established rules sometimes don't apply." Senior optical engineer Maria Santos, who had relocated from Barcelona to join the facility, demonstrated one of the advanced measurement systems. Her expertise in photonics had been crucial in developing new inspection capabilities that exceeded industry standards. "Your Highness, this system can detect defects that are literally invisible to conventional measurement techniques. We're working at the very edge of what's possible with current technology." "Maria's work has resulted in 3 patents already," Dr. Morrison added proudly. "She's part of our international talent recruitment program, bringing expertise from around the world while training local engineers in these advanced techniques." Prince William turned to Maria with interest. "What brought you to Wales for this opportunity?" "The chance to work on truly cutting-edge problems," Maria replied enthusiastically. "KLA has facilities worldwide, but this facility was designed from the ground up to pursue the most advanced research. The combination of excellent facilities, talented colleagues, and challenging projects made it an easy decision." "And how has the experience been, personally and professionally?" "Better than I expected," Maria smiled. "Professionally, I'm working on problems that didn't exist 5 years ago. Personally, the Welsh colleagues have been incredibly welcoming. My daughter is learning Welsh in primary school, something I never imagined when we moved here." Software engineer Peter Hughes, a local hire whose programming skills had been honed through online courses and community college training, joined the demonstration. His work developing control algorithms for the optical systems had quickly gained recognition from senior engineers. "Your Highness, I'm responsible for the software that controls these optical measurements. It's like conducting an orchestra, but with lasers and cameras instead of instruments." "Tell me about your background, Peter. How did you develop the skills for this type of work?" the prince asked. Peter's story was particularly compelling. "I was actually working in retail electronics for years, sir, but I spent my evenings learning programming and taking online courses in engineering. When KLA announced they were hearing locally, I took the risk and applied. The interview process focused more on problem-solving ability and learning potential than formal credentials." "That's quite a career transition. What has the learning curve been like?" "Steep but manageable," Peter laughed. "The senior engineers here are incredible mentors. They don't just tell you what to do, they explain the theory behind it. I'm essentially getting a world-class engineering education while doing actual engineering work." Dr. Morrison led them to the materials analysis laboratory, where chemist Dr. Jennifer Park was examining semiconductor wafer samples under powerful microscopes. Her expertise in surface chemistry had been essential in developing new cleaning and preparation techniques that improved manufacturing yields. Your Highness, at this level of manufacturing, contamination that's invisible to the naked eye can ruin entire batches of semiconductors. My job is understanding and controlling chemistry at the molecular level. The prince peered through one of the microscopes, seeing magnified images that revealed the incredible complexity of semiconductor structures. This gives you a completely different perspective on what electronics actually are. Exactly, Dr. Park agreed. Most people think of computer chips as simple objects, but they're actually among the most complex structures humans have ever created. Each chip contains billions of individual components, all precisely positioned and functioning together. Jennifer's team has developed cleaning processes that have increased our production yield by 12%, Dr. Morrison noted. In semiconductor manufacturing, that kind of improvement represents millions of dollars in value and significantly improved supply reliability. Mechanical engineer Thomas Edwards, whose work on precision positioning systems enabled the extraordinary accuracy required for semiconductor inspection, explained the mechanical challenges involved. A graduate of Cardiff University's engineering program, Thomas represented the successful integration of local talent with world-class technology. Your Highness, the systems we work with must position measurement equipment with accuracy measured in fractions of nanometers. To put that in perspective, if a nanometer were the size of a marble, a meter would be the size of Earth. How do you achieve that level of precision in a real manufacturing environment? The prince asked. It requires controlling everything, Thomas replied. Temperature variations, vibrations from footsteps, even air currents can affect our measurements. We've had to become experts not just in mechanical engineering, but in environmental control, vibration isolation, and thermal management. Thomas designed the isolation systems that allow us to maintain measurement accuracy even when heavy trucks pass on the nearby road, Dr. Morrison added. It's the kind of problem-solving that requires both deep technical knowledge and creative thinking. The conversation was joined by thermal systems engineer Rachel Williams, whose expertise in managing heat dissipation had been crucial in developing reliable high-power measurement systems. Her work ensured that sensitive optical components maintained stable operating temperatures even under demanding conditions. Your Highness, managing heat is one of our biggest challenges. The precision required for our measurements means that temperature variations of even a fraction of a degree can affect accuracy. How do you solve those thermal management challenges? The prince inquired. Through incredibly precise cooling systems, Rachel explained, leading him to a display showing thermal management equipment. We use advanced heat exchangers, precision temperature controllers, and even liquid nitrogen cooling for some applications. It's like climate control, but measured to tolerances that HVAC systems could never achieve. Senior Systems Engineer Dr. Kevin O'Brien, whose work integrating various subsystems into coherent measurement platforms had been essential to the facility's success, joined the discussion. His ability to coordinate complex engineering projects while maintaining technical excellence had made him a key figure in the facility's development. Your Highness, what makes this facility special isn't just individual technical achievements, but how we integrate everything into systems that work reliably in manufacturing environments. Integration must present its own unique challenges, the prince observed. Indeed it does, Dr. O'Brien confirmed. Academic research can focus on optimizing individual components, but manufacturing requires systems that work together flawlessly for months at a time. Our engineers must think about reliability, maintainability, and ease of use, not just technical performance. The prince was introduced to electronics engineer Lisa Thompson, whose expertise in high-frequency circuit design enabled the rapid data processing required for real-time measurement systems. Her work developing custom electronics had been crucial in achieving measurement speeds that kept pace with high-volume manufacturing. Your Highness, the signals we're processing happen incredibly quickly. Our electronics must capture and analyze data in microseconds while maintaining extraordinary accuracy. What's the most challenging aspect of designing electronics for these applications? The prince asked. Noise management, Lisa replied immediately. At the sensitivities we require, electronic noise from everything around us can interfere with measurements. We have to design circuits that can extract incredibly weak signals from environments filled with electromagnetic interference. Lisa's designs have achieved signal-to-noise ratios that were considered theoretical limits just a few years ago, Dr. Morrison noted. Her work enables measurements that simply weren't possible with conventional electronics. The tour continued through the computational engineering section, where algorithm development engineer Dr. James Mitchell was working on machine learning approaches to measurement optimization. His background in artificial intelligence had brought new capabilities to traditional measurement challenges. Your Highness, we're applying AI techniques to problems that have traditionally required expert human judgment. The goal is to combine human insight with computational power. How does artificial intelligence apply to semiconductor measurement? The prince asked with obvious curiosity. Pattern recognition, primarily, Dr. Mitchell explained. Human experts can look at measurement data and identify subtle patterns that indicate problems. We're training AI systems to recognize those same patterns, but to do it faster and more consistently than human operators. The applications are remarkable, added data scientist Sarah Roberts, whose work analyzing manufacturing data had identified optimization opportunities that improved both efficiency and quality. By analyzing thousands of measurements, we can identify trends and correlations that would be impossible to spot manually. It's like having a microscope for data instead of materials. Prince William spoke with automation engineer Mark Davis, whose programming of robotic systems had enabled the precise handling required for delicate semiconductor components. His work bridging mechanical engineering and computer programming had been essential in achieving the reliability required for volume manufacturing. Your Highness, our robots must handle semiconductor wafers that are thinner than paper and worth thousands of dollars each. The precision and reliability requirements are extraordinary. How do you program robots for such delicate operations? The prince inquired. Layers of safety and precision control, Mark explained. Every movement is programmed with multiple fallback options. If anything deviates from expected parameters, the system stops immediately. We literally cannot afford mistakes at this level of operation. The conversation expanded as process control engineer Dr. Amanda Foster joined the discussion. Her expertise in statistical process control had been crucial in maintaining the consistency required for high-yield manufacturing. Your Highness, in semiconductor manufacturing, consistency is everything. Small variations that would be acceptable in other industries can cause complete product failures here. How do you maintain that level of consistency across such complex processes? The prince asked. Continuous monitoring and feedback, Dr. Foster replied. We measure everything, analyze the data in real time, and make adjustments before problems can develop. It's like conducting an orchestra where every instrument must play precisely in tune, all the time. Reliability engineer Colin Hughes, whose work predicting and preventing equipment failures had been crucial in maintaining production uptime, demonstrated predictive maintenance systems that monitored equipment health continuously. Your Highness, in high-volume manufacturing, unplanned downtime can cost hundreds of thousands of dollars per hour. Our job is predicting problems before they happen. What indicators do you monitor to predict equipment failures? The prince asked. Everything that can be measured, Colin replied. Vibration patterns, electrical currents, temperature variations, acoustic signatures. We're essentially monitoring the vital signs of every piece of equipment, looking for early warning signs of potential problems. The technical discussions revealed not just sophisticated engineering capabilities, but a culture of continuous learning and innovation. Senior engineers worked closely with recent graduates, sharing knowledge while encouraging fresh perspectives on established problems. The collaborative environment had fostered innovation that exceeded what individual engineers might accomplish working in isolation. Test engineer Dr. Michelle Roberts demonstrated validation systems that ensured every measurement system performed to specification before entering production service. Her meticulous approach to verification had been essential in maintaining the facility's reputation for reliability. Your Highness, we test our measurement systems more thoroughly than most products are tested before sale. Reliability at this level requires extraordinary attention to detail. What does comprehensive testing involve for systems this complex? The prince inquired. Months of operation under every condition we can simulate, Dr. Roberts explained. Temperature extremes, vibration, electromagnetic interference, power fluctuations, anything that might affect performance. We stress test systems until we understand exactly how they behave under all possible conditions. As the afternoon progressed, the prince engaged with engineers at all career levels, from recent graduates to industry veterans. Each conversation revealed different aspects of the technical and human challenges involved in pushing the boundaries of measurement science. The facility represented not just advanced technology, but a successful model for combining international expertise with local talent development. Calibration engineer David Price, whose work ensuring measurement accuracy had been fundamental to the facility's credibility, explained the complex procedures required to maintain traceability to international standards. Your Highness, our measurements must be accurate not just relative to our own standards, but to standards used worldwide. Maintaining that traceability requires constant vigilance and periodic verification. How do you verify accuracy at these scales? The prince asked. Through carefully maintained reference standards and regular comparison with other metrology laboratories, David replied. We're part of an international network of measurement laboratories that continuously verify each other's capabilities. It's the only way to maintain confidence in measurements at these precision levels. The technical discussions had revealed extraordinary depth of expertise and innovation, but equally important was the evidence of knowledge transfer and skill development. Experienced engineers from around the world were working successfully with local talent, creating a unique environment where cutting-edge research flourished alongside practical manufacturing requirements. As the engineering tour concluded, Prince William had gained deep appreciation for both the technical achievements and the human collaboration that made them possible. The facility represented far more than advanced manufacturing. It demonstrated how investment in both technology and people could create capabilities that exceeded what either could achieve alone. The afternoon shift was beginning as Prince William moved into the heart of the production areas, where the sophisticated equipment developed by the engineering teams operated under the skilled hands of production workers. These were the men and women who transformed theoretical capabilities into actual manufactured products, working with precision and dedication that made the facility's reputation possible. Production supervisor Helen Morris, a former textile worker who had successfully transitioned to semiconductor manufacturing, greeted the prince at the main production control station. Her journey from traditional Welsh industry to high-tech manufacturing embodied the economic transformation that the facility represented for the region. Your Highness, welcome to our production floor. What you'll see here is where all the engineering and design work becomes reality. Helen has been instrumental in developing our production procedures, noted facility operations manager Steve Richards. Her ability to combine manufacturing experience with new technology requirements has been invaluable. Helen smiled at the recognition, her confidence evident after 2 years of mastering complex new skills. The transition wasn't always smooth, sir. Semiconductor manufacturing requires a completely different approach from anything I'd done before. But the training here was exceptional, and now I can't imagine working anywhere else. Prince William observed the bustling activity around them, noting the obvious coordination and precision involved in every operation. What was the most challenging aspect of transitioning to this type of work? Learning to think in terms of absolute precision, Helen replied thoughtfully. In textiles, close enough was often good enough. Here, close enough means failure. Every measurement, every procedure, every decision must be exactly right. It changed how I approach not just work, but everything in my life. Machine operator Carl Jenkins, whose attention to detail had made him one of the most trusted operators of the facility's most sensitive equipment, demonstrated the complex procedures required for wafer handling. His steady hands and methodical approach had earned respect from both colleagues and supervisors. Your Highness, these wafers represent months of work and significant investment. When I'm handling them, I'm responsible for protecting all that effort and value. How do you maintain the concentration required for such precise work? The prince asked, watching Carl's careful movements. It becomes second nature after a while, Carl explained, never taking his eyes off the equipment. But it started with understanding exactly what these components do and why precision matters. When you know that your work affects products used by millions of people, you find the motivation to be perfect every time. Carl has achieved error rates that are among the lowest in the industry, Steve Richards added. His dedication to quality exemplifies the work ethic we see throughout our production team. The prince was introduced to quality inspector Diana Evans, whose eagle eye for detail had prevented countless defective products from reaching customers. Her previous experience as a jewelry appraiser had provided excellent preparation for the microscopic inspection work required in semiconductor manufacturing. Your Highness, my job is being the last line of defense against defects. If something imperfect leaves this facility, it's my responsibility. What kind of defects are you looking for at this level of manufacturing? The prince inquired. Diana guided him to an inspection station where microscopic images revealed the incredible complexity of semiconductor structures. Scratches smaller than bacteria, particles invisible to the naked eye, dimensional variations measured in atoms. What you're looking at here would be completely invisible without our specialized equipment. How do you train your eye to recognize such microscopic defects? Months of practice and mentorship from experienced inspectors, Diana replied. But the key is understanding what normal looks like so thoroughly that abnormal becomes immediately obvious. It's pattern recognition at an almost subconscious level. Production technician Mark Williams, whose mechanical aptitude had made him essential for equipment maintenance and troubleshooting, explained the daily challenges of keeping sophisticated systems running reliably. His background as an automotive mechanic had provided excellent foundation skills that translated surprisingly well to high-tech manufacturing. Your Highness, these machines are incredibly sophisticated, but they still have moving parts that need maintenance and adjustment. The precision required is just much higher than anything I worked on before. How does maintaining semiconductor equipment compare to automotive work? The prince asked with genuine curiosity. Mark laughed, wiping his hands on a perfectly clean cloth. The basic principles are the same, sir. Mechanical systems need lubrication, alignment, and regular inspection. But the tolerances here are measured in nanometers instead of millimeters. A tiny vibration that wouldn't affect a car engine at all can throw off our measurements completely. Mark's preventive maintenance protocols have reduced our unplanned downtime by 30%, Helen Morris noted. His ability to anticipate problems before they cause production interruptions has been invaluable. The conversation continued with clean room technician Sarah Davies, whose responsibility for maintaining the pristine conditions required for semiconductor manufacturing had made her an expert in contamination control. Her previous experience as a laboratory assistant had prepared her for the meticulous attention to cleanliness required in the facility. Your Highness, contamination control at this level is like being a detective. We're constantly looking for sources of particles that are too small to see but large enough to ruin products. What are the most common contamination sources? The prince asked, nodding the elaborate procedures involved in maintaining clean room conditions. Human beings, Sarah replied with a smile. Even with all our protective equipment, people are the biggest source of contamination. Skin cells, hair, fibers from clothing, even the salt from perspiration can cause problems. Managing human activity in clean environments is an art form. How do you balance operational efficiency with contamination control? Through careful procedure development and constant training, Sarah explained. Everyone who works in clean areas must understand not just what to do, but why it matters. When people understand the science behind the procedures, they're much more likely to follow them consistently. Process monitor Anthony Roberts, whose job involved continuously tracking production parameters to ensure optimal performance, demonstrated the sophisticated control systems that governed manufacturing operations. His background in process industries had prepared him well for the demands of semiconductor manufacturing. Your Highness, every aspect of our production is monitored in real time. Temperature, pressure, chemical concentrations, timing, everything must stay within very narrow parameters. What happens when parameters start to drift outside acceptable ranges? The prince inquired. Immediate action, Anthony replied, pointing to multiple monitoring screens. Sometimes we can make adjustments to bring things back into specification. Other times we have to stop production until we understand and correct the problem. The key is catching deviations before they affect product quality. Material handler Jennifer Price, whose responsibility for managing the flow of components through the facility required both precision and efficiency, explained the complex logistics involved in semiconductor manufacturing. Her background in warehouse operations had provided excellent preparation for the material management challenges. Your Highness, timing is everything in semiconductor manufacturing. Components must arrive at each station exactly when needed, in perfect condition, with complete documentation. How do you coordinate such complex material flows? The prince asked. Computerized tracking systems and old-fashioned attention to detail, Jennifer replied. Every component has electronic identification that tracks its location and status continuously. But computers can fail or give incorrect information, so we also maintain visual verification of everything. Jennifer's material management procedures have eliminated storage errors completely, Steve Richards noted. In an industry where misplaced components can cost thousands of dollars, that level of reliability is extraordinary. Maintenance scheduler Gary Hughes, whose planning and coordination ensured that equipment maintenance occurred without disrupting production schedules, demonstrated the sophisticated systems used for maintenance management. His experience in industrial maintenance had been enhanced by specialized training in semiconductor equipment. Your Highness, scheduling maintenance in a facility like this is like solving a three-dimensional puzzle. Every piece of equipment has different maintenance requirements, and production schedules must be maintained. How do you balance maintenance requirements with production demands? The prince asked. Through predictive maintenance and careful scheduling, Gary explained. We monitor equipment condition continuously and schedule maintenance based on actual need rather than arbitrary time intervals. This allows us to minimize maintenance-related downtime while ensuring reliability. Environmental technician Louise Morgan, whose work monitoring and controlling environmental conditions had been crucial in maintaining the stable conditions required for precise manufacturing, explained the complex systems involved in environmental management. Her education in environmental science had provided excellent preparation for the unique requirements of semiconductor facilities. Your Highness, environmental control here goes far beyond normal HVAC systems. We control not just temperature and humidity, but air purity, chemical concentrations, and electromagnetic interference. What are the most challenging environmental control requirements? The prince inquired. Particle control, Louise replied immediately. We must maintain air cleanliness levels that are thousands of times cleaner than normal indoor air. This requires sophisticated filtration systems, careful control of air flows, and constant monitoring of particle levels. The prince spoke with documentation specialist Emma Thomas, whose meticulous record-keeping ensured complete traceability of all manufacturing processes. Her background in administrative work had been enhanced by specialized training in quality management systems. Your Highness, documentation in semiconductor manufacturing isn't just record-keeping. It's about maintaining complete knowledge of every step in every process for every product. Why is such detailed documentation necessary? The prince asked. Traceability and continuous improvement, Emma explained. If a customer reports a problem with a product manufactured months ago, we must be able to trace exactly what happened during its production. This allows us to identify and correct problems before they affect other products. Assembly technician Robert Price, whose skilled hands assembled complex measurement systems with precision that exceeded what most people could achieve with simple tasks, demonstrated the manual dexterity required for high-precision assembly work. His background as a watchmaker had provided excellent preparation for the precision assembly requirements. Your Highness, modern semiconductor equipment still requires human hands for final assembly and adjustment. Machines can't match human judgment and dexterity for complex assembly tasks. How do you maintain the precision required for such complex assemblies? The prince asked, watching Robert's steady movements. Practice and patience, Robert replied, continuing to work while speaking. But also understanding exactly how each component functions and why precision matters. When you understand the engineering behind what you're building, precision becomes natural. Shipping coordinator Michelle Edwards, whose responsibility for ensuring products reached customers in perfect condition had made her an expert in protective packaging and logistics, explained the final steps in the manufacturing process. Her experience in logistics had been enhanced by understanding of the special requirements for shipping precision equipment. Your Highness, our products often travel thousands of miles and must arrive in perfect condition. The packaging and shipping procedures are as critical as the manufacturing processes. What special considerations apply to shipping such sensitive equipment? The prince inquired. Vibration control, temperature management, and contamination prevention, Michelle explained. These systems must arrive at customer locations ready to perform precision measurements immediately. Any damage during shipping could affect their performance for years. The afternoon had revealed not just skilled workers, but individuals who had found purpose and pride in their roles within a larger mission. From former miners to experienced technicians to recent graduates, the production workforce represented successful adaptation to technological change, while maintaining the work ethic and attention to detail that characterized Welsh manufacturing traditions. Night shift supervisor Paul Davies, arriving early to prepare for the evening transition, spoke about the unique challenges of maintaining production quality during overnight hours. His experience in continuous process industries had prepared him well for the demands of 24-hour semiconductor manufacturing. Your Highness, night shift work requires special discipline and attention. Without the full support staff available during day hours, our operators must be even more self-reliant and careful. How do you maintain quality and safety during night operations? The prince asked. Through careful procedures and excellent training, Paul replied. Night shift operators receive additional training in troubleshooting and problem-solving. They must be able to handle situations independently that day shift operators might resolve with assistance from specialists. Training coordinator Lucy Williams, whose responsibility for ongoing skill development had kept the workforce current with rapidly advancing technology, demonstrated the facility's commitment to continuous learning. Her background in adult education had been invaluable in developing training programs that worked for diverse learning styles and experience levels. Your Highness, technology in this industry advances so rapidly that continuous learning is essential. We provide ongoing training to ensure our workforce stays current with new developments. How do you design training programs for such diverse backgrounds and experience levels? The prince inquired. By focusing on practical application rather than theory alone, Lucy explained. We use hands-on exercises, mentoring relationships, and gradual skill building that allows people to learn at their own pace while maintaining production responsibilities. As the shift change approached, Prince William observed the careful transition procedures that ensured continuous production quality. The professionalism and coordination evident during the handoff revealed a workforce that took pride in their collective responsibility for maintaining excellence. The conversations throughout the afternoon had revealed workers who understood not just their individual responsibilities, but their roles within larger systems that produced products affecting millions of people worldwide. Their pride in their work was evident, as was their appreciation for the opportunity to be part of technological advancement while maintaining meaningful employment in their home communities. The production workforce had demonstrated that advanced manufacturing success depended not just on sophisticated equipment, but on skilled and dedicated people who brought both technical competence and personal commitment to their daily work. Their stories reflected broader themes of economic transition, personal growth, and community development that made the facility significant beyond its technological achievements. The executive conference room overlooked the main production floor, providing a panoramic view of the bustling activity that had impressed Prince William throughout his visit. As evening approached, he joined senior management and community leaders for discussions about the broader implications of the facility for Wales and the semiconductor industry globally. The conversations would explore not just technical achievements, but the strategic vision that had made this facility a catalyst for regional development. Managing Director Dr. Sarah Chen opened the session by presenting comprehensive data about the facility's impact since opening. Her presentation included employment statistics, economic contributions, and partnership developments that demonstrated how the facility had exceeded initial projections. Your Highness, when we announced plans for this facility 3 years ago, we projected significant positive impact. The reality has exceeded our most optimistic expectations. Prince William studied the presentation materials with obvious interest, asking detailed questions about sustainability metrics and long-term growth projections. The economic impact figures are impressive, but I'm particularly interested in the sustainability aspects. How do you balance growth with environmental responsibility? Through integrated planning from the beginning, Dr. Chen replied. Environmental sustainability wasn't an afterthought. It was built into every aspect of our design and operations. Our energy efficiency per unit of production is among the best in the industry, and we've implemented comprehensive recycling and waste reduction programs. Operations Director Steve Richards elaborated on the operational philosophy that had guided the facility's development. His experience managing manufacturing operations worldwide had provided perspective on what made facilities successful over the long term. Your Highness, sustainable operations require thinking beyond immediate production goals. We've designed processes that minimize resource consumption while maximizing output quality and worker satisfaction. What specific innovations have you implemented to achieve those goals? The Prince inquired. Closed-loop water systems, waste heat recovery, predictive maintenance that reduces resource consumption, and modular facility design that allows expansion without massive reconstruction, Steve explained. But perhaps most importantly, we've created a culture where every employee contributes to efficiency and sustainability improvements. Human Resources Director Linda Thompson presented data on workforce development programs that had become models for other facilities. Her comprehensive approach to talent development had created pathways for career advancement that benefited both employees and the company. Your Highness, our success depends entirely on our people. We've invested heavily in training, education partnerships, and career development programs that ensure our workforce grows with our technology. The career progression data is particularly impressive, the Prince observed. How do you balance promoting from within with bringing in outside expertise? Through structured mentoring and knowledge transfer programs, Linda explained. When we hire external experts, they're partnered with local employees for intensive knowledge sharing. This accelerates skill development while ensuring that expertise remains within the organization even as individual experts may eventually move on. Finance Director Michael Roberts discussed the economic impact that extended far beyond direct employment. His analysis demonstrated how the facility had created ripple effects throughout the regional economy, supporting suppliers, service providers, and related businesses. Your Highness, our direct employment is significant, but the indirect economic impact is even larger. We've created demand for everything from specialized construction services to advanced logistics capabilities. How do you measure and track these broader economic impacts? The Prince asked. Through partnerships with local universities and economic development agencies, Michael replied. We track not just our direct spending, but the multiplier effects throughout the supply chain. The data shows that each job we create directly supports approximately 2.3 additional jobs in the broader economy. Regional Development Manager Catherine Price, whose background in economic development had been crucial in coordinating with local government and educational institutions, presented information about partnership programs that had strengthened both the facility and the broader community. Your Highness, we've worked to ensure that this facility serves as a catalyst for broader technological development rather than just an isolated success. What specific partnerships have been most effective? The Prince inquired. Our relationships with local universities have been transformational, Catherine explained. We've established joint research programs, internship pipelines, and continuing education partnerships that benefit students, faculty, and our operations. These relationships have created a sustainable talent development ecosystem. The Prince was particularly interested in discussing community engagement initiatives with Community Relations Manager David Williams, whose work had built strong relationships between the facility and local residents. His background in public relations had been enhanced by deep understanding of community needs and concerns. Your Highness, industrial facilities can sometimes create tension with residential communities. Our goal has been to be genuinely good neighbors while operating a world-class manufacturing facility. What have been the most effective community engagement strategies? The Prince asked. Transparency and genuine involvement, David replied. We hold regular community meetings, provide facility tour for local residents, and maintain open communication about our operations and future plans. But most importantly, we hire locally whenever possible and support local charities and civic organizations. Technology Transfer Director Dr. Alan Morrison, whose responsibility for sharing knowledge with local institutions had helped establish the region as a center for semiconductor technology, discussed programs that were building technological capabilities throughout Wales. Your Highness, our goal isn't just to operate successfully here, but to help establish Wales as a recognized center for advanced manufacturing and semiconductor technology. How do you balance proprietary technology protection with knowledge sharing? The Prince inquired. Through careful program design that shares fundamental principles and methodologies without compromising competitive advantages, Dr. Morrison explained. We can teach measurement science principles, quality management techniques, and advanced manufacturing methodologies without sharing specific proprietary technologies. Supply Chain Manager Jennifer Roberts discussed efforts to develop local supplier capabilities that had strengthened both the facility's operations and the regional manufacturing base. Her work had created opportunities for Welsh companies to participate in global semiconductor supply chains. Your Highness, when we arrived, very few local suppliers could meet semiconductor industry requirements. Through supplier development programs, we've helped dozens of local companies upgrade their capabilities. What kinds of support do you provide to local suppliers? The Prince asked. Technical assistance, quality system development, and long-term purchasing commitments that justify their investments in capability improvements, Jennifer replied. We've essentially helped create a local semiconductor supply ecosystem that benefits everyone involved. Environmental Manager Louise Morgan presented comprehensive data on environmental performance that demonstrated the facility's commitment to sustainable operations. Her programs had achieved environmental impact levels significantly below industry averages while maintaining high production volumes. Your Highness, environmental responsibility is fundamental to our long-term success. We can't build sustainable business on unsustainable environmental practices. What have been your most significant environmental achievements? The Prince inquired. Water recycling systems that reuse 95% of processed water, energy efficiency improvements that reduce carbon footprint per unit of production by 40% compared to industry averages, and waste reduction programs that have achieved nearly zero landfill waste, Louise explained. But we're also working on next-generation technologies that will further improve environmental performance. Government Relations Director Robert Davies discussed coordination with Welsh Government and UK agencies that had facilitated the facility's development while ensuring compliance with all regulatory requirements. His work had helped create a framework for additional technology investments in Wales. Your Highness, successful industrial development requires effective partnerships between private companies and government agencies. We've worked to create models that can be replicated for other technology investments. How has government support contributed to your success? The Prince asked. Through workforce development partnerships, infrastructure investments, and streamlined regulatory processes that maintain high standards while enabling efficient business operations, Robert explained. The Welsh Government's commitment to advanced manufacturing has been crucial to our success and has attracted attention from other technology companies considering Welsh investments. Quality Director David Thomas presented data on quality achievements that had established the facility's reputation among global semiconductor manufacturers. His comprehensive quality management systems had achieved performance levels that exceeded industry benchmarks. Your Highness, quality in semiconductor manufacturing isn't just about meeting specifications. It's about exceeding customer expectations consistently over time. What quality management practices have been most effective? The Prince inquired. Statistical process control, continuous improvement programs, and comprehensive employee training in quality principles, David replied. But fundamentally, it's about creating a culture where everyone takes personal responsibility for quality, from senior management to newest employees. Research and Development Director Dr. Kevin O'Brien discussed innovation programs that had positioned the facility at the forefront of semiconductor measurement technology. His teams had developed technologies that were being adopted by manufacturing facilities worldwide. Your Highness, innovation in this industry requires balancing fundamental research with practical manufacturing applications. Our goal is developing technologies that solve real manufacturing challenges while advancing scientific knowledge. How do you coordinate research activities with production requirements? The prince asked. Through integrated project teams that include both researchers and production personnel, Dr. O'Brien explained. This ensures that research projects address actual manufacturing needs while maintaining scientific rigor. The result is innovation that has immediate practical applications. Security Director Margaret Hughes discussed comprehensive security programs that protected both physical facilities and intellectual property while maintaining open collaboration with partners and customers. Her experience in security management had been adapted to meet the unique requirements of high-technology manufacturing. Your Highness, security in facilities like this requires balancing multiple priorities. We must protect valuable technology and materials while enabling the collaboration and information sharing that drives innovation. What are the most challenging security requirements? The prince inquired. Cybersecurity and intellectual property protection, Margaret replied. Physical security is relatively straightforward, but protecting digital assets and proprietary information requires constant vigilance and sophisticated systems. We've implemented multi-layered security that protects against both external threats and internal risks. Training and Development Director John Phillips presented comprehensive workforce development programs that had become models for technology industry training. His programs had successfully prepared workers from diverse backgrounds for high-technology careers while maintaining high retention rates. Your Highness, workforce development in rapidly advancing technology requires continuous adaptation. Our training programs must prepare people not just for current jobs, but for careers that will evolve with advancing technology. How do you design training that remains relevant as technology advances? The prince asked. By focusing on fundamental principles and problem-solving skills rather than just specific procedures, John explained. When people understand the science and engineering principles behind their work, they can adapt to new technologies and methods as they're developed. Strategic Planning Director Amanda Foster discussed long-term planning that positioned the facility for continued growth and technological advancement. Her work coordinated facility development with global semiconductor industry trends and regional economic development goals. Your Highness, strategic success in this industry requires anticipating technological and market developments that may not emerge for several years. Our planning processes consider not just current opportunities, but future possibilities. What factors drive your long-term strategic planning? The prince inquired. Technology roadmaps, market analysis, workforce development trends, and regulatory environment evolution, Amanda replied. But perhaps most importantly, we consider how global semiconductor industry changes might create new opportunities for Welsh manufacturing and technology development. As the evening session continued, the discussions revealed a comprehensive approach to industrial development that extended far beyond manufacturing operations. The facility had become a catalyst for broader technological and economic development that was positioning Wales as a significant player in global technology industries. The management presentations had demonstrated not just business success, but genuine commitment to community development and environmental responsibility. The facility represented a model for how advanced technology companies could contribute to regional development while achieving commercial success and maintaining environmental sustainability. The breadth and depth of the programs discussed revealed an organization that understood its responsibility to multiple stakeholders, from shareholders and customers to employees and community members. The success achieved suggested that this approach created value for all involved rather than requiring trade-offs between different interests. The main assembly hall had been transformed for the closing ceremony, with employees from all shifts gathering to hear Prince William's reflections on his comprehensive tour of the facility. The setting sun cast warm light through the large windows, illuminating faces that reflected both professional pride and personal satisfaction in what they had accomplished together. This moment would mark not just the conclusion of a royal visit, but recognition of achievements that extended far beyond manufacturing excellence. Prince William took the stage to address the assembled workforce, his remarks reflecting genuine appreciation for what he had witnessed throughout the day. The depth of his engagement with employees at every level had prepared him to speak not just about technical achievements, but about the human stories that made those achievements possible. I came here today knowing that I would see impressive technology and learn about advanced manufacturing, he began, his voice carrying clearly throughout the hall. What I discovered was something far more significant. A community of people who have demonstrated that economic transformation is possible when technological innovation combines with human determination and collaborative spirit. The audience listened attentively as the prince reflected on specific conversations and observations from his tour. His remarks demonstrated that this had been far more than a ceremonial visit. It had been a genuine exploration of both technical capabilities and human potential. This morning, I met Tom Williams, who brought his family from California to help establish this facility. His story exemplified the international collaboration that has made this success possible. But equally important, I met Robert Davies, who transitioned from coal mining to high-technology manufacturing, proving that experience and determination can overcome any career transition challenge. Scattered applause acknowledged both the recognition and the broader message about economic opportunity and personal resilience. The prince's ability to remember individual names and stories demonstrated the personal attention he had given to each conversation. The engineering capabilities I witnessed today represent the absolute frontier of measurement science. Dr. Morrison's team is developing technologies that push against the fundamental limits of physics. But what impressed me most was seeing how that cutting-edge research translates into practical manufacturing capabilities through the skilled hands and careful attention of production workers like Carl Jenkins and Diana Evans. The combination of technical recognition with acknowledgement of production skills resonated strongly with an audience that included both research scientists and manufacturing technicians. The prince had successfully recognized the collaborative nature of their achievements. The management presentations this afternoon revealed something equally impressive: a comprehensive understanding that business success must include community development, environmental sustainability, and genuine commitment to employee growth. This isn't just advanced manufacturing, it's responsible corporate citizenship that creates value for everyone involved. Dr. Sarah Chen, watching from the side of the stage, felt deep satisfaction in hearing the facility's broader mission articulated so clearly. The prince had grasped not just what they were doing, but why they were doing it and how they were ensuring sustainable success. Prince William continued his remarks by addressing the broader significance of what the facility represented for Wales and the United Kingdom. His comments reflected understanding of both immediate achievements and long-term potential. Wales has a distinguished history in manufacturing and innovation. This facility honors that heritage while demonstrating that Welsh workers can master any technology and compete successfully in any global market. You've proven that investment in people, combined with access to advanced technology, creates capabilities that exceed what either could achieve alone. The pride evident in the audience reflected not just personal satisfaction, but genuine appreciation for recognition of their collective accomplishments. Many had doubted whether such a facility could succeed in Wales. The prince's remarks validated their confidence and hard work. The partnership model you've developed here, bringing together international expertise with local talent, creating pathways for career advancement, and maintaining commitment to environmental responsibility, should become a template for industrial development throughout the United Kingdom. Regional development officials in the audience exchanged satisfied glances, knowing that such endorsement from Prince William would enhance their efforts to attract additional technology investments to Wales. The prince then shifted his focus to individual achievements and personal stories that had impressed him throughout the day. His remarks demonstrated the personal connections he had made and his appreciation for the human dimensions of technological success. I was particularly moved by conversations with employees who had made significant career transitions to join this facility. Peter Hughes, who moved from retail electronics to software engineering through online learning and determination, represents the kind of individual initiative that makes economic transformation possible. Sarah Davies, who applied laboratory skills to contamination control in semiconductor manufacturing, demonstrated how existing skills can be adapted to new technological requirements. These personal recognitions meant more to the individuals involved than any formal awards could have provided. Having their contributions acknowledged by Prince William validated not just their professional achievements, but their personal courage in embracing change and new challenges. The apprentice program represented another impressive achievement. Meeting Amy Chen, who chose this path over traditional university education, reminded me that there are multiple routes to professional success and meaningful careers. The combination of practical experience with advanced technical education provides preparation that universities alone cannot match. John Phillips, the apprentice coordinator, felt particular satisfaction in this recognition. His program had faced initial skepticism from those who questioned whether apprenticeships could work in high-technology industries. The Prince's endorsement would strengthen support for expanding such programs. Prince William addressed the facility's role in advancing semiconductor technology and its global significance for supply chain security and technological independence. The work being done here contributes to global technology supply chains that affect billions of people worldwide. But beyond economic impact, this facility enhances British technological capabilities in industries that are crucial for national security and economic independence. Your contributions strengthen not just Welsh manufacturing, but British technological sovereignty. This broader strategic perspective resonated with employees who understood that their daily work had implications extending far beyond immediate production goals. Recognition of their contribution to national technological capabilities added another dimension to their professional satisfaction. The Prince then offered observations about the collaborative culture he had witnessed throughout his visit, noting how it differed from more hierarchical industrial environments. What struck me most profoundly was the collaborative spirit evident at every level of your organization. Senior engineers working closely with recent graduates, experienced managers learning from frontline workers, researchers collaborating with production personnel to solve practical problems. This isn't just good business practice. It's a demonstration of human potential when people work together toward common goals. The audience recognized this as an accurate description of their daily experience. The collaborative culture had developed naturally as people focused on solving complex problems rather than maintaining traditional hierarchies. The environmental achievements you've accomplished deserve particular recognition, proving that advanced manufacturing can operate sustainably, that economic development can enhance rather than degrade environmental quality, provides a model that should be adopted throughout British industry. Louise Morgan, the environmental manager, felt deep satisfaction in this recognition. Her team had worked diligently to achieve environmental performance levels that exceeded regulatory requirements while maintaining production efficiency. Prince William concluded his formal remarks by reflecting on the broader lessons that his visit had revealed about economic development, technological advancement, and human potential. Today has reinforced my conviction that Britain's future prosperity depends not just on financial investment or technological innovation alone, but on our ability to combine both with genuine commitment to human development and community responsibility. This facility demonstrates that such integration is not only possible, but profitable. The sustained applause that followed reflected appreciation for both the recognition and the broader vision that the Prince had articulated. His remarks had elevated their achievements from local success to national significance. Following the formal address, Prince William spent additional time in personal conversations with employees who had particularly impressed him during the tour. These informal exchanges provided opportunities for more detailed discussions about both technical and personal aspects of their work. Margaret Hughes, the security director, spoke with the Prince about the unique challenges of maintaining security while fostering the open collaboration essential for innovation. Your Highness, balancing security requirements with collaborative culture requires constant attention, but the results prove that both can be achieved simultaneously. How do you think other facilities could learn from your security approach? The Prince asked. Through careful attention to culture as much as technology, Margaret replied. Security systems that create barriers to legitimate collaboration will eventually fail. Effective security must enable rather than impede the work processes it protects. Dr. Kevin O'Brien, the research director, discussed with the Prince the challenges of maintaining research excellence while meeting immediate production requirements. Your Highness, the integration of research and manufacturing has exceeded our expectations. Researchers gain practical perspective that improves their work, while production personnel develop deeper understanding of the science behind their processes. Do you see this integration model being adopted elsewhere? The Prince inquired. I believe it's essential for competitiveness in advanced technology industries, Dr. O'Brien replied. The separation between research and manufacturing that worked in previous eras doesn't match the pace of technological change we face today. Linda Thompson, the Human Resources Director, spoke about workforce development programs that had achieved retention rates exceeding industry averages. Your Highness, our success in workforce development comes from treating employees as whole individuals rather than just workers. Career development, personal growth, and family considerations all affect job satisfaction and performance. What advice would you give to other companies developing similar programs? The Prince asked. Invest genuinely in people's growth, not just their immediate productivity, Linda replied. Long-term thinking about human development produces better business results than short-term focus on immediate output. As the evening progressed, informal conversations revealed additional insights into both the technical achievements and human dynamics that had made the facility successful. The Prince's continued engagement demonstrated sustained interest rather than mere politeness. Steve Richards, the operations director, discussed the challenge of maintaining production schedules while accommodating the continuous learning and improvement that kept the facility at the technological forefront. Your Highness, balancing operational efficiency with innovation requires accepting that some experiments will fail. Creating an environment where intelligent failures contribute to eventual success is crucial for technological advancement. Catherine Price, the Regional Development Manager, spoke about coordination with local government and educational institutions that had amplified the facility's impact throughout Wales. Your Highness, industrial development is most successful when it strengthens rather than displaces existing community capabilities. Our partnerships have enhanced educational institutions and local businesses rather than competing with them. The conversations continued as employees shared their perspectives on working at the intersection of cutting-edge technology and traditional Welsh work ethic. Their stories revealed how international collaboration, advanced technology, and local capabilities had combined to create something stronger than any component could achieve alone. As the visit concluded, Prince William offered final observations that summarized his impressions from the comprehensive tour and extensive conversations. His remarks reflected appreciation for both immediate achievements and long-term potential. This visit has exceeded my expectations in every dimension. I expected to see impressive technology and learn about advanced manufacturing. Instead, I discovered a model for economic development that combines technological excellence with human fulfillment and community responsibility. The example you've established here provides hope and direction for industrial development throughout Britain. The facility's success represented more than business achievement. It demonstrated possibilities for economic transformation that preserved community values while embracing technological advancement. The Prince's recognition validated efforts that had required courage, determination, and sustained commitment from everyone involved. As Prince William departed, the employees returned to their responsibilities with renewed appreciation for their individual contributions to collective success. The visit had provided external validation for achievements they had recognized internally, but it had also articulated a vision of their work's broader significance that would sustain motivation through future challenges. The facility continued its operations as the Prince's convoy disappeared into the Welsh evening, but the impact of his visit would endure in enhanced confidence, strengthened community relationships, and increased recognition of what Welsh workers could accomplish when provided with appropriate opportunities and support. The day had demonstrated that industrial success in the modern economy required more than technological capability or financial resources. It demanded genuine commitment to human development, environmental responsibility, and community engagement. The KLA Newport facility had achieved that integration, and Prince William's visit had recognized and celebrated their accomplishment for audiences far beyond Wales.